Don't worry, it's only 1 hour of maths, okay?
There's 1 hour.
Ah, 4 to 5 is cancelled. Yeah.
Switch to no.
Yeah. It's good news for you. Good news. Okay. So this lesson here is the last lesson in chapter 2, which is means that everything up until today could be on the exam you have after the holiday. Okay. Right. So this word here, inequalities. Inequalities means when we have this or this one or this one. So smaller than, or equal, greater than or equal. Or you could say less than, more than, whatever you want is fine. So this is the smaller or equal, greater or equal. Okay. Now, I show people this. Which one is bigger? B. And then which one's bigger? B. Okay, so just be careful. So remember, Pac-Man eats the bigger one. You all know Pac-Man, don't you? Of course you do. Look. Okay. Oh no, I don't have yellow. Alright. Okay. So let's have a look at some examples. So these problems, they're really similar. It seems like they're really similar to what we've done already. So if I had something like this, and I want to solve it, I would say minus 5x minus x. Well, you know what? I'll take it the other way around. I'll say minus 6, and then this, and then here we go. So what I did was I took the 6 to the left and the minus 5x to the right. So you got minus 6 is smaller than 6x. So then x is bigger than or equal to minus 1. And if you were to draw that answer, it means here's 0, 1, minus 1, 2, 2. You're saying that if x, you need x to be bigger than or equal to minus 1. So to show that I want the minus 1, I colour it in and then draw the arrow going this way. Bigger than minus 1. You sometimes have this. And the way we show that on the number line is we draw an open circle, which means not including minus 1. But we do want minus 1, so I'll colour the circle in. So this is the answer for the first example. So write that down. And so far it looks just like a linear equation. But there are some special rules we have to consider. It's not always quite like this. Okay, do you have that yet? So it seems like, alright, this is just like what we've done so far. But there is one special exception. If I scroll down now. So suppose I have 5 is smaller than 6. And now I multiply both sides by minus 1. Is minus 5 smaller than minus 6? No. Minus 6 is smaller. So this is the exception. Whenever we multiply or divide by a negative number, the sign gets flipped around. Okay? So if I have a greater than b, that gets flipped around. If I put minus on both sides, I have minus a smaller than minus b. So we just need to take care with this, okay? Just be careful. When you have a minus and you multiply or divide, it flips it. Only multiply and divide. It's not a problem if I did something like this. If I did a -1 and a -1, still no problem. It's only when I multiply or divide. That's all where I need to be careful. Okay, I can scroll down now. Okay, so I want to introduce some special symbols here called sets. Okay, so the first one, this here, or, this is short for all real numbers. Basically, for us, it means everything. So this means everything. All real numbers. Since we don't look at complex numbers, for us this is everything. The next one, Z, this is called integers, and these are all the numbers, minus and positive, yeah, for which, the first one, or the second one? Yeah, it's -3, hang on, dot, 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 -3, -2, -1, 0, 1, 2, 3, etc. These are the integers. Some people call them whole numbers because they're full numbers. No decimals, full numbers, the integers. Positive and negative. The next one is called the rational numbers, and these are all the numbers which are fractions. Where P and Q are whole numbers, and of course Q is not 0. Question? No? I think we need to close the blind or something. It's a little bit hard to see this. Good? No, it's not for me. I don't like looking at students. They make me feel bad. I feel kind of sick. Alright. So Q here are the rational numbers, which means they're all the numbers that are fractions. Okay. So we have R, Z, Q. And the last one, N. What do we think N is? Natural numbers, starting with... Do we start with 0 or not?
No, 1, 2, 3.
Well, I'll tell you, it's not clear because some books start with 0 and some do not start with 0, so there is some confusion. Unfortunately, there's not one choice that everybody uses. So to prevent confusion, when I do want you to include 0, I will write a 0 here, meaning yes, I want the 0 in it. And when I don't want the 0, then to show that clearly, I'll put a little star here. But unfortunately, if I just write N by itself, I could mean this, or I suppose the book or the exam or whatever you're reading, it could mean either situation. Unfortunately, like I said, it's not a universal definition unlike the others. So maybe in your country they included 1, maybe they didn't. Yes? Never seen W, we'll stick with N. Yes?
So, when you put an M, so do I include the 0 or not?
If what?
If there's an M without a star or a 0. I do whatever I want.
I wouldn't say do whatever you want, but if I was to, it shouldn't happen in the exam because it's not clear, but if for some weird reason it happened and you had to make a choice, and you were forced to make a choice, probably choose the one without the 0. So, I'd go with this one, okay? Worst case. Okay. Now, this isn't the only sets we have. These are just the ones which are common everywhere. Real numbers, integers, rationals, and natural numbers. But sometimes we just want to include numbers between 2 points. Like for example, if I go down there, suppose I want all the numbers between, let's say, 6 and 7. So that would be like 0.6, 0.52, all these numbers. The way we represent that is with brackets like this, square brackets, 6, 7. What this means is all the numbers between 6 and 7. Okay, and this has a name. This is called a closed set. So just to be clear, if I write this, it means I'm talking about all the numbers between A and B, including A and B. It's called a closed set. This one is called a open set. When I write it like this, the meaning is very similar. It means all the numbers between A and B, but we don't include A and B. So this is called an open set. Yeah. Now, in fact, you can have them mixed as well. So something like this, that would be all the numbers from A and B, and you include A, but you don't include B. And of course, the other way around is also possible. If I have the close at the end, this would be all the numbers from A and B, don't include A, but do include B. Now, what also is convenient is we can stitch them together. So for example, if I write something like this, 1 to 2, union, that's what this symbol here means, union, 3 to 4. What that means, if I draw it on the number line, 0, 1, 2, 3, 4, sorry, let me fix that. 0, 1, 2, 3, 4. The numbers from 1 to 2, including 1 and 2, whoops, 1 to 2, and then also union numbers 3 to 4, including 3 to 4. So you know, like 1.5, 3.1, 4.0, numbers in here or in here. That's what this means. This is called union. And you would have done this in middle school. Maybe even some people did it in their last grade of elementary school. Probably not though, but you would have done this in middle school. Okay, so we have union here. And the last thing I want to show you, which is convenient, is the to exclude. So for example, if I write this, all the numbers from 0 to 10, including 0 and 10, exclude 6.2. That means every number from 0 to 10 except the number 6.2. So on the number line it would look like this. 0 all the way up to 10, there's 5. So it would look like this. From 0 all the way up don't include 6.2, and then all the way back up to 10. Okay, so that's what it would look like. I'm missing one person. I'm a die. Where's that? Okay, that's yeah. No, I'm not missing that. They're here. Missing one person. Who is it? Must be a science student, because I don't know physics. No? And I have everyone. I just couldn't see everybody when I was counting. That's alright. I have everyone. No need to panic. Okay, next example now. Okay, so suppose I want to solve something like this. Minus 11 is smaller than this number, minus 4x plus 5, which is smaller than 13. And I also tell you x is a natural number including 0. So I want to know what are the possibilities for x that makes this true. Now, there are two ways to do this problem, and I'll show you both ways, and you can pick which way to do it in the exam. The first way to do this problem is to do it as two smaller problems. First we look at this, and then we look at this. And we want and between them. They both must be true. So I have minus 11 minus 6 is smaller than minus 4x. Minus, what the heck happened there? Minus 11 minus 5 is smaller than minus 4x. Minus 16 is smaller than minus 4x. So then 4 is bigger than or equal to x. That's the first one. Minus 4x is smaller than 13 minus 5, x. Minus 4x is smaller than 8. So x is divided by minus 4 bigger than minus 2. Now again, it's and. We want both of these things to be true. So if I look at the number line here, there's the number 4, and I want my x to be smaller than 4. If I look here, I want my x to be bigger than minus 2. But I want both. I want it to be smaller than 4 and bigger than minus 2. So in other words, I want this. Between minus 2 and 4. So, my x is between minus 2 and 4. Finished? No. Yes. Not finished because of this. I also tell you x is a natural number. So this means I can't even use minus 2, minus 1. But I can use 0, and 1, 2, and 3 and 4. Star means no, oh sorry, star, not 0. Not 0, so I can use 1, 2, 3, and 4, is it? Yeah. So I can only use 1, 2, 3, and 4. So my answer is actually this. X is possibly 1, 2, 3, or 4. And that's the answer. In the exam, it is so common for students to stop here and not get full marks. You must continue to get full marks. Okay, write that down. And in a moment, I'll show you the second way you could do it. Oh yeah, I can't quite see that. Will I scroll down a bit? So I'll just write it again, and I'll do it now in a moment, the second way to do it. So this second way to do it is what I would recommend for the exam. It is a little quicker than the first way to do it. Okay, so to do it the quicker way, what we do first is we put a -5 on everything. So here I write -5, here I write -5, and here I write -5. Yeah? They cancel, so now on the next line I have -16 smaller than -4x smaller than 8. Then what I do is I divide everything by -4. So now I get 4 4 bigger than or equal to x, bigger than or equal to -2. In other words, x is to be between -2 and 4. And again, same thing at the end. Well, we can only use the natural numbers, so we have 1, 2, 3, 4 as the answer at the end. So you can see that's a lot quicker to do. Okay.
This is not the number to -1.
Yeah, because it's a natural number. It's not -1. We can't use that. I'll give you one to try, and then we'll move on to more difficult ones. So I'll write this one down for you to try. Let's say here -7, and then 3x plus 11. And then 17, and I'll make it a bit easier for you. I'll say x is a real number. Okay, it should only take you a minute to do this. Give it a try. Okay, so we'll have -7 minus 11, and then 3x, and then 17 minus 11, so that's -18, 3x, and 6, so that's -9, no, 6, sorry, -6x, and 2. So there you go, x must be between -6 and 2. Including both and everything in between, because it's a real number. So much easier to do these when we know that x is a real number. Much easier to do. Okay, so far we've looked at linear inequalities. Next we'll look at quadratic inequalities. Okay, so I'll scroll them down. So what about something like x squared minus 3x plus 2 positive or equal 0? How do we do this? Say again? Yeah, well, first things first. We need to factorize it before we can really do anything. So we have here x minus 2 x minus 1 greater than or equal to 0. Now what we do next, there are two ways of doing this again. So I'll show you both ways. I'll show you the easier way first, and the second method some people prefer it, so I'll show you that in a moment. We graph this, very, very quickly graph it. What are the roots here?
2 and 1.
And what shape is it?
U.
A U shape. And this here, remember, is the x. Now, whoops, is the x. Now look, if x was here, is the y positive or negative?
Negative.
No, the y. Positive. And then what happens to the y when I hit here? 0y. And then if I'm here, the y is negative. And then when I get back to 2, it's back to positive. Now what do I want? I want positive. So that means I should use this piece and use this piece on the number line, but not this piece. So then the answer is x must be smaller than 1 or bigger than 2. And that's the answer. It's just like that. So there's nothing too complicated here. Now, like I said, there are two ways to do this, so I'll show you the second way in a moment. So you can see why it was important that we learned how to solve the quadratic and draw the quadratic, because if you can solve and draw quickly, then you can do this quickly. There is another way to write this answer though, which you may need to do in the exam. If they ask for the answer as a set, then the answer as a set is minus infinity to 1 and then 2 to infinity here. That's the answer as a set. You can see minus infinity to 1, that's this piece, and then 2 to infinity, that's this piece, and then the u is putting them together. Okay, so the second way to do this now. X squared minus 3x plus 2 needs to be positive. Again, at the start it looks the same. We factorize it. Why is there Starbucks coffee on the floor there? Is that one of yours? Make sure you take it at the end. Okay, so how do we do this the second way? Well, if you think about it like this, what type of numbers do I multiply to make a positive number? Well, this must be positive, and this must be positive, or there's another way to make a positive. Both negative. Yeah, negative and a negative. So if I write that down here, we have positive and positive, or negative and negative. So let's look at both. For both to be positive, I need x minus 2 to be positive and x minus 1 to be positive. That means I need x to be bigger than 2 and I need x to be bigger than 1. Now, I am reminding you the importance of the word and here. And here is telling me I need both to be true. I must have x bigger than 2 and I must have x bigger than 1. There's only one way both of those can be true at the same time, and that is if x is bigger than 2. It's the only way both can be true, and I'll show you on the number line. So here, is our number line. If here's 1 and here's 2, I need x to be bigger than 1, and I need x to be bigger than 2. The only way I can have both to be true at the same time is if x is bigger than 2. So this answer over on the left is saying x is bigger than 2. That's what I get. But there's a second answer, or both negative. So I have x minus 2 smaller than or equal to 0. X minus 1 smaller than or equal to 0. X must be smaller than 2. X must be smaller than 1. So what is my answer here? When can I make both true? Smaller than? Come on, you got a 50-50 chance. Which is it?
1.
Yes. So if here's 1 and here's 2, I want x to be smaller than 1 and smaller than 2. The only way both can be true at the same time is if x is smaller than 1. So if you put your answers together, you have x must be smaller than 1. That means minus infinity to 1. And x must be bigger than 2. Oh, sorry, we can include 1. And x must be bigger than 2. So 2 to infinity. So they're both acceptable. So that's the answer. So it's the second way to do it. I hope you agree with me. The first way is better.
From 1 to infinity. Minus infinity.
Minus infinity to 1. Yeah. And then 2 to infinity. Both answers. Okay, let's have a look at another example of this one. It's a tiny bit more complicated. Minus 7x squared minus 41x minus 63 smaller than minus x squared. Okay. Now this looks much more difficult, but it's not really, because all I have to do is take this to the left. So now I get minus 6x squared minus 41x minus 63 is smaller than or equal to 0. If I don't like the minus here, I can just multiply everything by minus to get rid of it. 6x squared plus 41x plus 63 bigger than or equal to 0. Right, factors. I feel like this is going to have to be like a 9 and a 7 and a 6 and a 1, or a 3 and a 3. 6 and no, too tired to do this. No lunch. Oh, geez. Alright, so if I use my minus b formula, A is 6, B is 41, 63. The answers are minus 7 over 3 and minus 9 over 2. So the two answers are minus 7 over 3 and minus 9 over 2. Minus 7 over 3 and minus 9 over 2. They're the two answers here. You use the formula, use factorize it, whatever way you want to solve it. Okay? So again, I want it to be positive, so that means I want to use this piece or this piece. So my answer is minus infinity to minus 9 over 2, and then minus 7 over 3 to infinity then. All the numbers up to minus 9 over 2, and then all the numbers after minus 7 over 3. So these aren't too difficult to do. Okay. One more example and then I'll let you try some. And in this one here, I tell you x is a natural number including 0. Okay. Now this one here, it looks like what we did earlier with the linears, that you think, oh, maybe there's a quick way to do it if I try and do some counting, but unfortunately not. For these types of problems with quadratics that are between two numbers, I have to do them as two separate problems. So we'll do them as two separate problems. Okay, so on the left we have 71 is smaller than 2x squared plus 20x plus 49, and (2x squared plus 20x plus 49) is smaller than 97. So here I get 2x squared plus 20x, and then 49 minus 71. What's that? 22. Minus 22, is it? Minus 22. That should be positive. And here I get 2x squared plus 20x. And then what's this one? 49 minus 97, 50, 46? 48, sorry. Can we double check that? 49 minus 97? Negative 48. Smaller than 0. Okay. Here I can divide by 2, and so I have x plus 11 and then x minus 1. So if I draw this, here is my 1 and here is my minus 11, and I want it to be positive, so that means I have x is smaller than minus 11, or x is bigger than 1. Now I do the same thing here. I can divide by 2. X squared plus 10x minus 24 is to be negative. So here, let me see, 12 and 2. X plus 12, x minus 2. 2 and minus 12. Yeah. Now, which piece do I take here? Please be careful. Here I want it to be negative. So I now, in this example, use this piece because I want it to be negative. So this is x must be bigger than minus 12, or well, not or, but rather and smaller than 2. So I don't like writing it like this. The way I like to write it is x must be between minus 12 and 2. So x must be between minus 12 and 2. Now this isn't finished yet, because now we have to put both answers together because of the and here. We want both of them to be true because the and. Oh, I guess this will be our last example. Okay, so now combining the answers. Here is, well, I'll put it on one large number line. Here is 1, 2, minus 11, minus 12. So in red, this can be the red one. X is to be smaller than minus 11. So here it is here. Or bigger than 1. So here it is here. And then this one here, I want x to be between minus 12 and 2. Now when you look at this, you must choose the piece where both the red and the green are true at the same time. So in blue, that happens in two places. Here, they're both true, and here, they're both true. So it looks like the answer is minus 12 to minus 11, union 1 to 2. Yes?
Numbers should be natural. So
Exactly. The numbers now must be natural. So I can't use this.
yes.
And I can't even use this because I don't want all the numbers between 1 and 2. If I only use natural numbers, then what's my answer? 1 and 2. 1 and 2. Not 1 to 2. Just 1 and 2. So this is actually the answer here. X is the number 1 or the number 2. So actually, I misspoke earlier. I won't take one of your chemistry classes because the math class later is cancelled, so I don't need to do a swap or anything. So you don't have math at 4 o'clock. Homework here. Do we have 1 hour tomorrow? We have 1 hour tomorrow. Yeah. Give me the first 5 in each. First 5. First 5 in each. Now look, I'll tell you something about those guys out there. In semester 2, I was doing some complicated problems on the board, and as part of the problem, there was something like this inside a bigger problem. And one of the students asked me, oh, how did you get the answer here? And I said, I'm not telling you, because I did it in semester 1. So, you know, you need to have all this knowledge, don't relax. Don't worry. You need to have all this knowledge going into semester 2. I'm going to assume that you're learning and revising and studying. The semester 2 builds on semester 1. So I know 5 from each seems like a lot, but you really need to learn the skills here. Okay? So the first 5 in each one. And in fact, I did some of them as well, so it's not even 5. Yeah?
Sorry.
Alright, we'll finish that, so